All right, let's talk about one of the classics. This is a brain teaser that Google has supposedly used to find some of the sharpest minds around. And it's one of those logic puzzles that just seems completely impossible when you first hear it. But stick with me, because the solution is so elegant, it might just change how you look at solving problems altogether. Let's dive in. Okay, so here's the challenge for you. You've got 1,000 bottles of wine, but one of them is poisoned. To figure out which one, you've got just 10 rats and only 24 hours for the poison to work. So the big question is, how do you find that one poison bottle? I mean, really think about that for a sec. It just feels overwhelming, doesn't it? Let's just let that number sink in. 1,000 bottles. I mean, that is a huge number. The sheer scale of the problem is it's meant to feel intimidating, It's designed to make you feel like you're up against the wall.
And what do you have to solve this massive problem? Just 10 rats. That's it. This is the key right here. This constraint is what makes the whole puzzle so clever. You've got this gigantic problem and basically no resources to solve it. Or so it seems.
So naturally, your first thought might be, okay, I'll just give one bottle to each rat. Simple enough, right? But wait, that only lets you test 10 bottles. You've still got 990 left. So yeah, that brute force approach, it's a complete dead end. We have to be way smarter than that. We need a system.
So what's the secret? Well, the breakthrough here has nothing to do with rats or poison, really. It's all about information. It's about learning to think like a computer. And the key to the whole thing is a concept you've definitely heard of: binary. This is the moment the puzzle goes from no way to, oh, I see.
So let's reframe this whole thing. Instead of thinking one rat, one bottle, what if each rat could represent something bigger? What if the fate of each rat, whether it lives or dies, wasn't just an outcome, but a piece of a code, a clue that helps us solve the mystery?
Okay, quick refresher on binary, just in case. It's basically a language with only two options, 0 and 1, on and off, that's it. But here's the magic. When you string those zeros and ones together, you can represent literally any number you can think of. Each of those little zeros or ones, we call that a bit. And this is the big aha moment. Think about it. Each rat has exactly two possible outcomes, right? It lives or it dies. So what if we assign a value to that? Let's say a rat surviving is a 0, and a rat dying, that's a 1. All of a sudden, our 10 rats aren't just rats anymore, they're 10 living, breathing bits of data. And this is where the math just gets awesome. If you have 10 bits, the number of unique combinations you can make is 2 to the power of 10, and that equals 1,024. 1,024. We only have 1,000 bottles. So, with our 10 rats acting as 10 bits, we have more than enough power to give every single bottle its own unique code. Problem solved. In theory. Okay, so the theory is solid. But how do you actually do it? How do we set up this experiment so that the pattern of dead rats literally spell out the number of the poison bottle? Well, it takes a really clever, really systematic approach. Let's walk through how it works. It's actually surprisingly simple once you see it. First step, you number all your bottles, 1 through 1,000. Easy. Step 2, you take each of those numbers and convert it into its 10-bit binary code. Then, you give each rat a job. Rat 1 is in charge of the first bit position, rat 2 gets the second, and so on, all the way to rat 10. And now for the big rule, a rat only drinks from a bottle if its assigned bit.
Let's make this super concrete. Take bottle number 1. In binary, that's a bunch of zeros and then a 1 at the very end. Since only the first bit position has a 1, only rat 1 drinks from it. Okay, what about bottle number 2? Its binary code has a 1 in the second position, so only rat 2 takes a sip. Now it gets interesting. Bottle number 3, its binary code is 1, 1 at the end. That means both the first and second positions are 1s, so, yep, both rat 1 and rat 2 have to drink from bottle 3. You just follow this exact same pattern for all 1,000 bottles.
And now, for the payoff. The truly brilliant part. After 24 hours, you go and check on the rats. You're going to build a new 10-digit binary number. Here's how. You look at the rats from 1 to 10. If the rat is alive, you write a 0 in its spot. If it's dead, you write a 1. What you end up with is a binary number. And that number is the number of the poison bottle. So let's say rat 1 and rat 3 died. The binary pattern would have a 1 in their positions. Convert that back to a normal number, and you get 5. Boom. Bottle number 5 was the poisoned one. So,
Okay, we cracked the code, we found the bottle. But let's be real. Why would a company like Google even ask a question like this? They're not in the business of poison testing, obviously. It's because the riddle isn't really about rats and bottles. It's a stand-in. It's a test for something way more important.
Yeah, this isn't about how fast you can do math in your head. Not at all. It's about something called structured thinking. Can you look at a big, messy, chaotic problem and see a logical system hidden inside it? Can you turn a real-world mess into clean, simple data?
Ultimately, this puzzle is a test. It's checking to see if you have a certain mindset. Can you convert a physical problem into a data problem? Can you solve things logically and systematically? And maybe most importantly, are you always looking for the most efficient way to get to the answer? It's all about that core binary logic that, let's face it, runs our entire digital world.
And that, right there, is the real takeaway. This way of thinking isn't just for weird brain teasers. It's an incredibly powerful mental tool. It's about taking complex issues and breaking them down into the simplest possible parts, a yes or a no, an on or an off. Once you do that, you can find patterns and build amazing solutions. So I'll leave you with this question. What's a complex problem in your life that you could simplify just by thinking in binary?